Example 5.7 is going to give us the same two functions that we had in example 5.6. We have f given by f of x equals x plus 4, and then g, which is given by g of x equals 2x plus 1. So same two functions, but now I want us to find an equation. I want us to write an equation for the following functions and then state the domains. So f composed with g of x is to be interpreted as f of g of x. So I'm not specifying exactly what value I want to start with. So since I don't have a starting value, all I can do at best is where it says g of x is replace it with 2x plus 1. Since I know that g of x is equivalent to 2x plus 1, I can do that. So this is going to say f of 2x plus 1. Now I'm supposed to take this 2x plus 1 and I'm supposed to substitute it in to the f function. So the f function says something plus 4. So this is now going to say 2x plus 1 plus 4. Combine like terms, and we're going to end up with 2x plus 5. And that gives us the equation for f composed with g of x. And I want to give you a little extra here. So going back to example 5.6, so hopefully you've already done example 5.6. If you haven't, you need to pause and do example 5.6 and then come back to this point in example 5.7. I want to give you a little extra. And I want to make a connection between the calculation we did in 5.6 and what we're doing here in 5.7. So I want you to take the composition that you just came up with, the equation you just came up with, and instead of doing f of g of x, I want you to do f of g of 2. And you're going to do that using the expression that you just calculated. So this is going to say then 2 times 2 plus 5, which is going to directly get you to 9. So on example 5.6, we had said, okay, we start with 2, and then we'll be able to calculate 5 by using g. And then if we use 5 with f, we will eventually be able to get over to 9. So we have to do it one step at a time. But what we just did was take 2 and go directly to 9. And the function that did that is called f composed with g. So by actually performing the composition with the equations, you can come up with a single map, a single function that will go straight from the very beginning all the way to the final answer at the end. So very powerful stuff here. So hopefully you'll see the appreciation there from 5.6 to what we're doing here in 5.7. So we'll come back and talk about the domains of part A and part B here in just a moment. What I'd like to do is go ahead and look at the equation calculation here for g composed with f. So we're using the same two functions again, but we're switching the order of the composition, and this is going to end up giving us a slightly different result. So I'm going to put this is equal to g composed with f of x. So I'm going to start with taking f of x, and I'm going to replace it with x plus 4, because I know that those two things are equivalent according to the equation. And then I'm going to take the x plus 4 and I'm going to use that as the input for g. So where it says x in the equation, I'm going to replace it with x plus 4. So this is going to say 2 times x plus 4 plus 1. That'll be 2x plus 8 plus 1 after distribution, and then finally 2x plus 9. And that's going to give us the new equation for this new function called g composed with f. So we have both of the equations. I'll go ahead and box them in. 2x plus 5, 2x plus 9. So the only thing left for us to do is to then state the domain of g composed with f, and then also state the domain of f composed with g. So let's talk about this composition domain. Just look at your final equation and check to see, is there anything strange going on with that? And when I say strange, what I really mean is there any potential dividing by 0? Is there any square rooting going on? And if I look at part A result, 2x plus 5, right here, all I see is a multiplication and I see an addition. I don't see any division or square rooting. So that would imply that the domain should be all real numbers. But I also want you to go back and I want you to analyze the very first function that you're supposed to be using. In this case, I'm supposed to be starting with g of x. So let's come over here to g of x and look at 2x plus 1. And with 2x plus 1, I can make the same argument. All I have here is just a multiplication and an addition. So that would also lead me to believe that I should be having all real numbers. So notice that I'm not going to even look at f. All I'm going to look at is the final equation and the very first equation that I started with. And those are the two things I want to look at for my domain. So in this case, the domain is just going to end up being all real numbers. And I can perform that exact same analysis for g composed with f. So I'll do that for you quickly here. If we're looking at the final result, 2x plus 9, there's only a multiplication and an addition. So that would imply all real numbers. And if I look at the very beginning, I had to start with f of x for this one. So looking at f of x, the only thing I have going on in f of x is an addition by 4. So that certainly doesn't have any negative ramifications. So that would imply that the domain should also be all real numbers. So that will end up being our domain. So we'll box both of those in as the domains for our respective composite functions here.